non-fusion welding, soldering, brazing, and braze welding are considered as a pure non-fusion welding operations. Mechanism of joint formation. In non-fusion welding process, when the molten metal of filler rod is poured into the joint, it is getting wetted to surface of pattern material. During solidification, the surface atom present in the molten metal will try to share the energy with the surface atom of the parent material and produces surface alloy. Soldering. Animation shows soldering operation, which is mainly applicable for joining of wires in PCB, that is, printed circuit boards. Mechanism. Wetting of molten filler metal and alloy formation. Temperature. Less than melting point of metal to be joined. At 427 degrees Celsius, the tin present in the 50-50 lead and tin alloy gets evaporated. So, we are selecting temperature less than 427 degrees Celsius. Most commonly used filler rods, 50-50 lead and tin alloy. Commercially used. Heat sources. Air acetylene flames were used in olden days as heat source. Nowadays, electrical resistance heating method is used, called as soldering iron. Soft soldering. Use 50-50 lead and tin alloy. The strength of joining produced with this filler rod is low, therefore called as soft soldering. Hard soldering. Silver 40%, lead 30% and tin 30% as alloy is used as filler rod material. Strength of joint produced is high, so hard soldering is preferred. Thus, in space applications like aircraft, missiles, etc. In both cases of hard and soft soldering, operation up to a maximum of 2% of bismuth will be added, which reduces the melting point temperature of filler rod material and also increases the weldability of molten metal of filler rod with parent material. Brazing. In brazing, the joint is made by heating the base metal red hot and filling the gap with molten metal. Temperature at which joint is to be heated is less than melting point of metal to be joined and more than 427 degrees Celsius. Mechanism: wetting and surface alloy formation. Filler rod material: copper alloy. Example: copper and zinc. Lowest melting point temperature of filler rod material used here is 420 degrees Celsius. So, we are using temperature more than 427 degrees Celsius. Heat source: oxyhydrogen flame. Average temperature 700 to 900 degrees Celsius. In brazing, the flow of molten metal of filler rod is taking place due to capillary action. Copper-zinc alloy, brass. Out of different copper alloys, the liquid molten metal of copper-zinc alloy will have the highest capillary action. Therefore, copper-zinc alloy will be used as a filler rod material in brazing. Any metal which has melting point temperature less than 427 degrees Celsius cannot be brazed or braze welded, and it can only be soldered. Brazing methods: torch and filler rods. Ring of filler metal at entrance of gap. Foil of filler metal between flat part surfaces. Brazing and braze welding. Brazing: without joint preparation. Braze welding: with joint preparation. If two components are joined with joint preparation, it is called as braze welding. In braze welding, the flow of molten metal into the joint is taking place due to gravity force. Copper-tin alloy, bronze. Out of different copper alloys, whichever the alloy is having highest density will have highest gravitational force. The copper-tin alloy has highest density. Therefore, it is used as filler rod material. Whenever the joint preparation is possible, such places braze welding is used. Whenever joint preparation is not possible, brazing will be used. Two CI pipes can be joined by using braze welding operations. A crack present in CI pipe can be repaired by using brazing operation. For a given material, according to the strength, first preference, braze welding. Second preference, brazing. Third preference, soldering.